Hello, everyone. It is Johnny and I at
Hello.
4 o'clock a.m.
It
on
is
the.
Sunday night. No, Saturday night. Now it's Sunday morning.
It's Sunday morning. Yeah.
Yes.
Basically, we have to be really quiet. Our two roommates are,
Both dead asleep.
and we just wanted to say that this is not going to be an easy program. This took us collectively 14 hours to
Or
program.
more. We didn't really keep track, but at least 14 hours
So
of the two of us working on it together.
Yes, so be prepared. This video is going to be very long, and
Yep.
it's going to be probably very hard to follow because we didn't know what we were doing half of the time.
Yeah, we ended up going through a lot of complicated, convoluted diagrams on whiteboards and complicated debugging and more 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 debugging and then a lot more debugging. And a lot of problems happened and a lot of problems had to be fixed. But we finally got it working. We got ours submitted and we got that done.
Yeah,
So we can help you guys get something at least.
we finally this program we were able to get it to a 100%, luckily, but so
it is possible.
it's sad somehow. What we're planning on doing is I will be uploading a Google Drive folder and linking it to everyone in the description below. That will have 3 assertion cases.
Some of the tests that he uses in Canvas to grade your program so you can know what to be prepared for, because it took us time when we were submitting it and then hitting this random test case which we didn't expect to have to deal with, and then it took like another amount of time to fix it and to make it work with that problem, and then we'd submit the code again and there would be some new test case which we didn't prepare for given all of that.
Yeah, so we'll put those 3 in assertion cases up there and how to run an assertion case again in case you forgot.
And again, just to say, we're not giving you our actual code in the description because we don't want you to just completely copy and paste everything we've done. We're trying to help you understand it and be able to get it to work, and it will take a lot of time to get it all written out. Some things we ended up we used the cue from the textbook, we used our linked list from before, and we had to modify both of them to get them to work for how we wanted it.
So we actually, I don't think we had to modify actually either one of them. We just used a lot of functions in there.
I think we modified them a little bit to make them work with nodes.
Yeah, we did a little bit just because of class naming and stuff, but we just want to let you know as well, we won't give you those. You should have those on your own, but yeah.
And we'll briefly go through them. Not really, probably not, because at this point you should know at least what a queue is, and if you need help figuring out a queue,
It's
there's
in your
stuff online.
textbook.
It's on the textbook. You'll be able to figure that out. If you
That's-
don't know what a singly linked list is by this point, go back in the textbook. Go back to our previous homework assignment that we had on the singly linked list. You should be able to get them done. So we're not going to spend a lot of time at all talking about them in this video.
Yeah, most of the time that we're going to spend will be on
The graph and the functions.
graph and the functions. Specifically,
Shortest distance is probably the most complicated.
yes, shortest distance and your actual constructor.
Yeah, the constructor for the graph took a long time to figure out exactly what we need to put in.
So, well, I think now we're going to go ahead and head to bed, and this next part that you'll see will be done and edited
At some point
tomorrow or today.
hopefully with enough time for you guys to use it and it be of some value.
Yes, so yeah.
For your sake, I hope that he pushes it back a little bit so you'll be able to get it done. If you're not able to spend a lot of time on it tonight, if you have other homework, unfortunately we didn't have time to work on it together over break because we lost both of us had flash drives which we thought had the code on it, but somehow managed to get corrupted for both of us, so we weren't able to work on it until we got back. And we just got it done now. We're back today, and hopefully getting it up Sunday will give you enough time to get it done Monday.
Hopefully.
Is it due Monday night?
Yes, it's due Monday night, so
they can work on it Monday, get it done.
Yeah. So
good luck, everybody.
Yep. And
hopefully it doesn't take you 14 hours.
Hopefully not. Hopefully this video will be helpful. If you have any questions and you're having specific issues, feel free to email us. Our emails are in the end card. So yeah.
Here we go.
Yeah. Hello everyone. It is Johnny and I. We're back. Approximately.
We didn't change who we are. We're still the same people.
5 hours after we've recorded the intro.
Yep. And I got some sleep. I don't think Aaron did.
I didn't sleep. That didn't happen.
But by some sleep, I mean like 4 hours, and I'm still not processing things correctly. So this video might not be as useful as you want it to be, but we're really going to try our best.
So we're going to start at the beginning and start talking about the two things that we imported. We imported Scanner because it's Scanner and it's the most useful import known to man. The second one we imported is Arrays, and the reason why we did that is because later on in functions, it's much easier to just create an array of your final variables and then put them into a string using the toString function with arrays.
Also, arrays gives us the function arrays.sort, which is what we used for one of the functions which wanted our output sorted as opposed to the order that we found it in, which I believe is getCC, but I'm not sure. We'll get there. We'll see when we get there.
Yeah, we'll see when we get there.
Okay, nice.
See what I did.
So, public class graph. Let's talk about those public variables that we made there up at the top.
Okay, yeah. So we have an array of nodes, which is all of the nodes that we are creating. And the reason why we have this is so that way we can take an int, and if we pass it through that, the indice at that array is automatically going to be...
Okay. Before we even finish going through that, I want to explain something to you about the input in this program, which he didn't tell you, and we had to figure out. There's a lot of assumptions you have to make about what is going to be true about his input that he's giving us for each of the test cases. What will be true is that the value in each node is going to be true to its number that it's inputted. So if there's 3 nodes, there'll always be node 0, node 1, and node 2. And the value in node 0 is 0, the value in node 1 is 1, and the value in node 2 is 2. So the value and the index for the array all nodes are always going to be the same. So at some points we do reference them differently. There will be cases later on where we'll have arrays which it is not true that the index and the value are the same, because the nodes stored in the array are not all of the nodes, but it's, say, node 1 and node 2 because they're a subgraph. So then node 0 is in the 0 slot, but node 2 is in the 1 slot. So the index and the value aren't the same anymore. But for the case of our node array, all nodes, it will always be true that the index is the same as the value of the node at that point in the array.
Yeah, so basically, you can kind of think of it as of all nodes as kind of like a function, and you're going to pass it an integer, and you're going to get back a node. And whatever integer you pass, you'll get the node with the value of that integer, if that makes sense.
I mean, okay, that's an interesting way of phrasing it, but I get what you're saying.
So,
did you explain int nodes? I didn't listen. In total nodes? That's just the number of nodes that there are in the graph, which is the very first number inputted in the program.
Yes. So
I think in the test case it was 6. It just says 6.
Correct. And here's where it explains that as well. N is the total amount of nodes, and then A will be your parent node. And then you'll have a colon, which is the most annoying thing known to mankind. And then you'll have B and C or however many.
Also,
And those will be the nodes that are connected to the parent node.
we found out through complicated confusion that it will also, if it gives you n, that's not only telling you how many nodes there are going to be, it's telling you how many inputs there are going to be following it, because it does give you an input for every node. He never didn't give you an input for a node.
Correct.
So he'll never say there's 3 nodes, 0, 1, and 2. 0 is connected to 2, 2 is connected to 0. He will never not tell you about 1. And it'll always be in order. 0 is connected to 2, 3 is connected to nothing. It would be blank, I think. But I don't think there are any cases where there's any single connected components. And then 2.
Basically, what he's trying to say is that
you can for loop it.
Yeah,
that's what we're saying.
You can for loop your inputs.
Yeah,
is what he's trying to say in less complicated terms. So let's go ahead and get on to the constructor. The constructor is debatably the most important part of your graph because it's what actually creates the graph. So we're going to start with a scanner. I called it IO because why not? Total nodes is going to equal the first integer that you get, and then we're just going to do a next line, and we're never going to use trash again.
Yeah.
Basically, this just we took the first integer, we took like that 6, but there's still a new line character. So next line, we'll take that new line character, and our cursor is now like on like the first line ready to start receiving inputs essentially.
Yeah. So we were having problems where it started at 6, and then it tried to get an integer following 6 on the same line because we didn't realize that we had to go to the next line.
So
pretty simple. You just got to make sure you're going to the next line after you collect that input.
Yep. And then we'll go ahead and initiate how long our array of total of all of our nodes is going to be, which, like we said, the length of that will always equal
that first
total nodes. However, the last node will always be total nodes minus 1. You make sure you remember that.
Because if there's 3 nodes, 0, 1, and 2.
So this for loop right here is really simple. It just creates all the nodes and with a default value of I, which is actually what you're supposed to do. Like we said, that's something that he doesn't tell you, but you should know it because
you just have to make assumptions.
So
yeah, and the reason you have to create nodes there is because when you're saying all nodes is a new node array, what that does is it creates an array with memory location to be able to store nodes, but it doesn't actually put any nodes in the memory location. So what we're doing is we're going to each index in all nodes and putting an array, not an array, we're putting a node there.
And since we're talking about nodes, we're actually going to go to the specific node class for this.
It's a little different.
Yes, it's a little different. So we have an integer value because we don't need to use generics, thank goodness. And then we're going to have a single linked list of edges.
And a single linked list of nodes. And each node is
its own thing. You can have a default constructor. I don't think you have to, but we just did because why not?
I think we might need it, but we added it.
The one that you use will be this one right here, and it just creates a node with the value equal to that, and you never start with edges.
You never construct it with any edges.
So
and if you don't quite get what edges are nodes because we decided there's 2 ways to program it. You could have edges be their own object type, or they could be aspect of the node class. So we just made it an aspect of the node class.
Yeah.
So node 0 is connected to 1. So in the singly linked list of edges,
if you were,
you would have 1
essentially
under the node 0.
Yeah. So you could kind of the way of thinking about it that we did is if rocks were nodes and if sticks were edges, we just said any stick that comes from a rock is connected to that rock and is a part of that rock, essentially.
I don't know if that made any sense, but okay.
Well, remember I got 0 sleep. So we're going to go back up here to graph, and we're going to continue on. So we have a boolean keep going equals true.
I don't think we used that.
We didn't actually use that, so
ignore that.
Don't worry about that.
Because we made it a for loop.
Yeah. So we have the current node that we're on, and the reason why that's not a node and it's an integer is because, like I said before,
He was tired and he didn't name it right.
that, and also if you think about the way that the integers work, you can pass all nodes in integer and you'll return a node. So that's basically what I did if I needed to reference that node.
That's the index or the value of the current node.
Correct.
That's both are the same.
So then we take a line of input and we create that string outside of the for loop. And then we create a string array, which is a string array of the input.
And then an int array, which is the int array of the input.
Yes.
So we'll show exactly what we're using each of them for in this for loop.
This is my little eureka here. So
this took forever to actually
this
get to
was
work.
the most annoying thing I think I've ever done. This entire thing was just horrible. But so okay, we're gonna take a line of input and we're just gonna say next line. That makes sense.
So this is already after we've collected the 6 and the new line character. This is the for loop going through all 6 of the following inputs.
Correct.
Yeah.
So
or
that
however many it will be.
That stupid, annoying little colon that we talked about before needs to go away because of stuff we're going to do later. So we're going to take line of input and just set that equal to itself, but we're going to replace the colon with a space. And you can do this with, this function will only take a char. And you can replace it only with a char.
We tried replacing it with null space and just getting rid of it, but we had trouble with that.
Yeah.
And we found a way to split on
the...
What is that noise?
I have no idea.
Sorry about that. You can split on any number of white space or spaces. So if there's one space, it'll split there. If there's 2 spaces, it'll split and get rid of both spaces.
Yes. So
we just replace the colon with a space.
Yes. And then whenever we go here, the split makes it into an array of strings. And we want to split it on either 1 or 2 white spaces. I don't know if your comp sci class has talked about this, but I know ours has. There are operators that you can use in most programming languages that mean like 1 or more, 0 or 1, none of these, all of these, operators like that.
That's string operators, yeah.
Yeah, so basically the plus is the 1 or more. The S is telling it that's a space, and the backslash, I don't actually
I think that's
understand.
telling it that it's an operator.
I think so as well.
Yeah. So there's an operator which is 1 or more spaces. That's what that means.
Yes. So we split on all the whites, all the spaces, all of the spaces.
So if there's a space, it means basically look until you find the next thing which isn't a space, and then put that into the next index of the array.
So, and then we're going to go ahead and create our int array, and it's going to be the same length as our string array. And then this for loop here, all it does is it converts all of our strings of numbers into integers of numbers.
Yeah, so it's for looping through the string array, parsing it using integer.parseInt, which turns the strings into integers. And because we got rid of the colon, everything in there should be able to be turned into an integer without problems.
Yes. The reason why this is probably at least from what I know, the best way to do this is because what we were doing before is we were just making them into a char array and then converting using ASCII. But we always use char at 0. So in test 3, for example, or 2, you see like we have a node that's 2 numbers. That would always just
12.
return 1.
Yeah, so
instead
it would think
of
it was
being
node
12.
2, and then it would read again and get node 2.
Yes.
And it was giving a lot of issue because of that. So you have to do integer.parseInt. So you can get an integer which is not just 1 character.
Exactly. That's greater than 9.
Yeah.
So then our current node is always going to be the first integer that we get. So we just go ahead and set it equal to that. And because that node is always that, we can start this next for loop at 1. And
So
then
this is no longer collecting the input, but while you're collecting the input, it goes through and it fills in all the edges and it interprets the input at the same places right when it gets it.
Yes.
So this is now interpreting our input.
So then interpreting our input, we're going to do the add edge function, which we'll talk about next.
Well, inside of the for loop, and the for loop is looping through the int array. Correct?
Yes, it's looping through the int array, so it'll get all the things from there.
So add edge is simple enough. You provide it two nodes, and it makes sure that they're both connected.
Yes, so you need to make sure that they're not already connected, because if you just start adding more edges to the same node, then your connected components will be wrong.
So if W is not in edges of V, add W to edges of V, and if V is not in edges of W, add V to W of edges.
Yeah. So that one's really simple, not that hard.
So is there anything else we need to do in graph, or are we good with graph?
I think we need to do shortest distance.
I mean, the constructor, though, we're good.
Oh, the constructor is done.
Okay.
We finished the constructor.
So let's do shortest distance first, because the other two are pretty similar to it.
Yes. So.
Actually, yeah, one we literally copied our shortest distance and then changed a few things.
Yes.
So this is based on breadth first search.
Correct. A reminder of breadth first search, if like you didn't pay attention in class or something, is that they use a queue and basically goes in levels outwards. So like if we start at node 0 and it's connected to nodes 1, 2, and 3, like one out would be all three of those nodes, kind of. So it's kind of hard to explain it without a whiteboard.
Yeah, and we did a lot of stuff with a whiteboard.
Yes.
So let me explain the level system real quick before we go line by line. We have a array which is called level array. What are you doing?
I don't know.
Okay, so we have a level array, which is what we're actually using instead of a count, or like keeping count of how many times. Well, that might be nice.
We're about to do this in Paint.
I don't know if this is going to happen, Aaron. Okay. What are you doing? I'm going to keep explaining this. So, the level array simply keeps track of how far deep you've gone into the, how many levels of breadth you've gone, I suppose is the way to word it.
Yeah.
And the way you do that, you'll see when we actually show you the lines of code for this. But
I'll draw this off screen.
okay. Where is it on there? Well, every time you add a node to the queue, you set its level array value, and the level array is the same size as the array of nodes, so its size is total nodes, which is that integer we have, which is in the beginning. So say it's 6 long, 0 to 5. Each index is related to the actual node, and then, oh, what he's drawing is useful. Yeah, bring that over.
Yeah. Alrighty. So basically, let's say that we started. If I can get my fill tool, I can't. Okay. So let's say we started that red node there.
Yeah.
The amount of
So the level for that node, so everything will be set in the level array to 0, and then your first node you set its level to 1, and then anytime you add and you're going through and you add something new to the queue, you set its level to what added it to the queue's level plus 1.
Yes. This is actually done wrong. 1 second. Let me.
What are you
it.
doing?
Never mind. Basically, this line should just.
Oh yeah.
This line should just skirt.
Oh yeah. Because that node in the middle is also depth.
Yeah.
Its level should be 2. And then, so what we're doing for returning is at the end we return the level of the node you wanted to see the shortest distance to, -1. It's level -1. Because say you're trying to get to highlight this node right here. Make it a different color, yeah. Say you're trying to get to That node. Okay, well, it's on level 1, 2, 3, so the shortest distance to get to it is 3 minus 1, which is 2.
Yeah. So,
Which makes sense if you follow the graph.
yep. Thank you, Microsoft Paint.
Yep.
Most underrated app ever.
Okay, so let's go through this real quick.
But okay, the reason why we have this is because we submitted our code, and it probably took like 10 minutes, I feel like. And then he gives you, in test number 2, he gives you a number that you have to find the shortest distance to that's greater than the maximum amount of nodes. So basically, we just said if the end is greater than total nodes, you can return -1, because that's what he wants to see. So give him what he wants.
And we had that right at the beginning because there's no point in going through the entire code for this if that's already the case.
Yes. So we're gonna start.
So you're taking. This is what he was saying with the function. You're making a node which is the node which would be at the value of int start2.
Yeah.
So all nodes of start2 gives you a node which is start now.
Yeah.
And then we do the same thing for n2, which gives you the end node.
And then
these are the node that you're looking for from n2.
Yes.
Yeah.
The next thing we're gonna do is make a queue, and we're not gonna show you how to make a queue because
The queue of nodes.
it's a queue of nodes. If you need and cannot absolutely find one, there is one in the textbook. You should be able to make your own queue. I feel like that's kind of explanatory on its own.
It's pretty similar to some of the, like a stack.
Yeah.
It just does things a little bit differently.
So, Boolean visited nodes. The reason why this is important is because it tells us if we've been there before or not. Because if we have, we obviously don't want to go there again.
Yeah, and we don't want to add something to our queue if it's already been visited before.
Exactly.
I don't think we use Boolean keep going.
I don't think so either.
Node current node is start.
Yes.
Do we use that? It says we don't use that.
It is not used, so don't worry about that.
And we don't use count either. Why do we keep all those variables?
I don't know. Just don't worry about 91 through 93.
Also, we don't even use end. Yeah, we do. Oh no, we use the n2.
Oh yeah, we don't even use end.
Yeah.
So, as you can see,
some of this stuff is redundant.
4 a.m. Johnny and Aaron really didn't care.
Yeah. Okay. The level array is what I was explaining though. It's an int array which is same size and dimensions and matches the all array thing, or all nodes array. So the index each refer to that certain node.
Yes.
So index 0 in level array is telling you what level node 0 is.
So we're going to go ahead and we're going to enqueue our start, because the queue is always where we're going to take our numbers to find the new edges.
Basically what we did for this is I pulled out my notes for breadth first search, and we directly put in breadth first search, and then we added
it from there.
All we really did was we added the level array thing.
Yes, because breadth first search on its own is automatically, I guess you could say, a shortest distance without being a shortest distance function.
Yeah. You find the shortest distance, and then it just normally returns like some weird ordered array of your stuff. We didn't do that.
And so instead of doing that, we're returning the amount of going outs it had to do.
Yeah, the amount of going out. Okay.
So obviously we're going to say that we visited start, and that we want to start our levels at level 1.
Yeah.
And we want to keep going up from there.
So say it's 0. Say we're starting at 0. We visited 0. Level array of 0 is now 1.
Yes.
And now, this is so cool. We found this out. We didn't know this was a thing. There's this thing called outer loop, and then later on, inside of a for loop, we hit an if statement which breaks outside of the outer loop. So it escapes both the for and the while loop.
Yes. This is very helpful, and we didn't know this, and
we found
thank goodness for Google.
Yeah, that is very useful, though, because we wanted to break out of the outer loop.
That wasn't a Zach thing either. That was actually Google.
Yeah.
So we were quite proud of ourselves. But
so yeah, let's go through this while loop.
All right.
While the queue of nodes
is not empty.
is not empty.
So we're going to go ahead and make a...
what's actually funny is we only put one thing in the queue, and then the first thing we do in this while loop is dequeue, so it becomes empty right away, but we end up putting stuff back in.
Correct. So don't... Yeah, so we're going to go ahead and make a temporary node of whatever's in our queue. And then what this is saying... Oh my goodness, Rooster Teeth.
You're getting so many notifications.
So...
Go ahead and explain that, because I don't get that at all.
Okay.
That first part. I get what iteration is, but what is...
Node 2 is the node class that's inside of single linked list. And we need that because that node class has the connection to the next edge. So we need to be able to know what it's connected to next. So the way to get the inner class from it is you do the outer class with the generic dot the inner class name, and then we set it equal to iteration, and then that will equal temp.edges, which is a single linked list, and then you can go into that single linked list and say I want the head,
which will be the first node that is connected to.
Yes, and the thing is that the value of iteration will be equal to the value of the node that is specific to graph.
Yeah.
So you can use that value, put it into node array, or all nodes, and get out the proper type of node that we need.
Yeah. So iteration is basically just a node which we're going through and changing, and it's this node is connected to the parent node. The parent node is temp. So temp is connected to, say, 0 and 2. So iteration, as it goes through the for loop, will be 0 in the first time through, the second time through it's 2, and then it's done.
Yeah. So...
And we can do stuff and use that value.
Yeah, so while we still have edges, is basically what this is saying. While we still have edges in the... in the single linked list.
If there's 2 edges connected to temp, then temp.edges.getSize is 2 will run through the for loop twice.
Yes. So if we haven't visited the node before, at iteration.value, which... Okay, so the reason why we do value.value is because iteration.value is a node. Because the value that we're putting into the single linked list are nodes. So iteration.value gives us a node, and then if you take the dot value of that node, you get an integer, which you can then put into visited nodes.
Yeah. So if visited, but it really is just the number inside of that node at iteration. So say we're looking at 0, which is connected to 1 and 2. So we're looking at 1 first. 1 is the first edge. So have we visited 1? That's the question.
Yes.
It looks more complicated than it really is. Have we visited it?
So if we haven't visited it, we're going to set it... Okay, well now we have.
Yes.
So we're going to set it to true. We're going to add it to our queue, which you could think of our queue as all the nodes that we've hit, but we haven't seen its edges yet.
Yeah.
So we're going to add it to the queue because we don't know its edges yet. And then level array. This
is where it's different than breadth first search.
Yes.
So what this is what I was explaining before. So level array, so say we're looking at 0 as the parent node, and then iteration is 1 right now. So we didn't hit 1, it's true, we enqueue it to the list, and then you set level array at index 1 equal to level array at the value at level array, which we set to 1 plus 1, so now it's level 2.
Yes.
Because we've gone in another layer deep.
So if we have... So what this statement is now saying is if we hit the end at any time, if that ever becomes true, we stop the entire thing. We close everything down,
important.
we leave, we don't come back, we burn the building, we break out of Azkaban.
Yeah, if that was our print statement.
Yeah.
So if you visited the end, which that means you found what you're looking for. You don't need to keep doing breadth first search. If you have like 100 nodes and you want to find the shortest distance from 0 to 5, you go 0, you get to 5, you see that it's 3. You don't need to go through and search the rest of the 100 nodes and keep adding stuff to the level array, because you know the value of what you're looking for. And you know that value when you hit visited nodes. When visited nodes is true for the end value.
Correct. So all this if statement is saying is that if you haven't hit the last value in the linked list, go ahead and iterate to the next thing in the linked list.
So that's basically
just like
the job. If we were doing this in Python, we wouldn't have to do that, because we would be doing something. If you remember Python, you'd just do like for variable name in temp.edges.
Yeah.
And that variable name would go through that list of edges. But because it's Java, we're doing the for loop based off of the size of the edges, and then every time we have to move on through the list at the end of the for loop.
Yeah.
So that's just moving on as long as we didn't hit the end.
So, and then we get out here. If we never visited the node that we wanted to hit, we return a -1. That means that there was no path from the node we started at to the node that we wanted to finish at.
Yeah.
Otherwise, we're going to take the level array value at the end, and we're going to subtract 1 from it, because you're supposed to start at 0, but we like starting at 1 because Skyrim.
There was the reason we started at 1 was not because Skyrim. There was a reason. The reason we started at 1 is because at first I was thinking what we would do for the other if statement would be if level array of it is 0, you return -1, else return it +(-1).
Yeah.
So what I wanted to make sure was that the starting node and the nodes that we don't hit don't have the same level value. That's why.
So
I don't know if it actually ended up mattering, but conceptually it made more sense for the node that you started on to have a different value than the nodes that you never touch.
correct. So now we're going to go on to count CC, which means we only have this in the next one, luckily. So count CC, a connected component, is basically let's get paint back up. Basically, the best way to describe it is that if you have two different graphs, if you have that, and that, and these are connected, and those are connected, those are two connected components. However, if we add this,
There's one connected
component. Basically, the best way that we thought about it is it's the amount of subgraphs, essentially. So
Yeah.
you have your big overarching graph, and then it's like, okay, this is my entire graph. But inside my entire graph, there's no way to get from there to there or there.
Yeah.
So those two are kind of on their own island. So I'm going to count that as one, and then they're on their own island. I'm going to count that as a second one.
Yeah.
So, yeah.
This one was pretty complicated, but I think we didn't change this one at all yesterday. We did this before break. I don't know if we changed it much.
We changed that.
Oh, yeah.
So, we're going to start at node 0, always.
Yeah, because you're not passing it anything. All you're doing is you're just counting how many total there are.
Yes.
You're not saying how many components are there if you look at this specific node. It's just a generic thing. Yeah.
So, basically, we're going to say, okay.
So we have a variable node, problem child, which is very important. So what it does is pull over that paint. So say we're looking at here. Can I have the mouse for a second? Say we're looking at how do you fill? Where's your filler thing? This one there. So say we're looking at this node right here, and then we check. Say this is node 0, and this is node 1. This is node 2. This is node 3. So we're at 0. We look at 1. We're like, okay, we can get there. And we'll explain how we know that we can get there later. But then you look at node 2, and you realize that you can't get there. So what you do is you mark node 2 as a problem child. Now, what you want to do is when you hit node 3, you don't want to mark it as a problem child, even though it is one that you can't hit. Because the problem child is
already on its separate island, and we don't want to just
so what we're doing is we go through and we count, and we make the subgraph of all of the things that are here, and then we go and we check the any problem child. So we if we realize that there's another problem child still that we didn't account for before in the red section,
yeah.
then we know that we need to make a third problem child and go check that, and that would mean that there's a third subcomponent or subgraph of it.
Exactly. So,
Which is why we have the Boolean array Ben problem child, because after we hit check 3 and we check 1 again, 1 would be a problem child compared to 3, but 1 has already been a problem child because it was our starting node, and the starting node is set to be the problem child.
exactly.
So since 1 has been the problem child before, we don't set it to the problem child again when you're doing checking 3. Same goes for 1 and 0.
Yeah.
Because 1 and 0 are in that component, in that subgraph. What are you drawing over there in Paint?
I am just actually creating their thing.
Oh, is that the actual program?
Yeah.
That's the first test, right?
Yes, this is the first.
So show them what you're doing.
So,
Oh, you're trying to get it working. Okay, so I'll go through this for a little bit more. We also have Ben put, which is the Boolean array. Again, same size as all arrays, the total number of nodes. But what that tells you if it's been put into the... What does it mean it's been put into? I forget. We'll see when we're using it. Why are they so small, Aaron?
Shut up.
Okay, here. Okay, I'll forget Ben put for a second. We'll explain that when we hit it in the code, because I don't recall exactly what that is.
Ben put basically is another way of saying, have we visited it, and does it connect?
Has it been put in a subgraph, basically?
Correct.
Okay. Ben problem. So what we do first is we set Ben problem child of 0, which is the first node that we're starting at, to true.
Correct.
Do we use count and temp? We do use count and temp. Okay. So we set count equal to 1 because we've already went through a node already, which is node 0. And we set temp, which is the index of the current node that you're looking at, I believe.
Yes? Sorry, I'm still trying to get this set up.
He's working on a fancy graph over here for you to look at.
Okay, there we go. That's done. Now, where are we in the code?
I just finished this part, so we're at the for loop now.
Okay, so for this, we're going to iterate through all of the nodes and think of y as being the first integer that we want to call. So y would be, okay, we want to start at 0. So we want to find all the connected components of 0. So everything's going to be in one for loop. And then if the problem child is null, then we'll explain why that line makes sense later. But we're going to do the x's now. So, okay, is 0 connected to 1? X is like what you're going to. Is 0 connected to 2? Is 0 connected to 3? No? Then that's going to be marked as a problem child. We now have a problem child.
So now we don't need to make another problem child.
So, is 0 connected to 4? No, but we already have a problem child, so we don't need to set it as 1.
You can only have one problem child at a time.
Exactly. And is 0 connected to 5? Yes. So we now know that all 5 of those, there we go, that all 5 of those are connected. So we don't need to actually go through and see why they're connected. 0, seeing as how it was the first starting node, is also going to be the first problem child. So we've set that as a problem child, and then we say, okay, well, 3 was our other thing. Is it connected to 0? No. It's already been a problem child. Has it connected to 1?
Now, what we're doing is we're not checking there if it's been a problem child. We're checking if it's been put.
Yes.
Yes. So has 0 been put?
Yes. Has 1
Then
been
it can't
put?
be a problem child. Has 1 been put? Then it can't be a problem child. Has 2 been put? I think they're actually checking both.
Yeah, I think it's actually...
Where is that? If statement. Yeah, not been problem child and not been put. Because if it has been put or it's been a problem child before, you don't want to make it a problem child.
Exactly.
Now, and if you do make it a problem child, it means it hasn't been a problem child before. Say when you made 3, it wasn't a problem child before. 3 has not been put. Problem child is not null, and temp is -1. Why would temp be -1 there? Explain that.
Temp. Let me go back up here. Int temp. If
temp is the shortest
temp
distance.
is the shortest distance. So basically, it's saying if there isn't a path, we return -1 from shortest distance.
So it means there isn't a path, which would be making it a problem child.
Yeah.
So from 0 to 3, the path is -1 because you can't get there.
Yeah.
Problem child isn't null. It hasn't been put, and it's not been a problem child. So then you make it a problem child. Set been problem child to true for it, and increment count.
Yes. And then we do this else if statement if temp is not equal to -1, meaning that's connected to the node and it hasn't been put yet, we're going to put been put to true. Because there's no reason to keep overriding a true with a true with a true with a true every time that we go through. So, and then we go back up here. Say we did all of them.
Yeah, so we made it through all of the things for 0. Now we're going to go look at 1.
Is there a problem child now? Yes. We've
But
set problem
it's 3
child
and it's
to
already
3.
a problem child. So going through 1 is y, going through 2 is y, won't change anything. Now we hit y is 3, right?
We hit y as 4. Or, yeah, we would hit y as 3.
So if problem, but if it's problem child, oh, never mind. Yeah. So then you go through, and that's when it's going to add another thing for problem child.
Yeah. So, hopefully that made sense.
Honestly, there probably is something we could do to make it shorter. Like,
probably,
if it's been put, you
works.
just break.
It works. I don't care.
That might be a thing, but it might be higher time complexity than it needs to be for that, but it works.
So, that's the biggest thing. So now we're going to get all the connective components of
Is this the last function that we're doing?
This is the last function that we're going over. Because we're already at 41 minutes.
So this one, you give it a specific...
If we gave it 0, the array would need to say 0, 1, 2, 5. Because this is also the one that has to be sorted.
Yeah.
So...
Because in the input... The way that it put the edges into 0 is 2 and then 1.
Yes.
So if you don't sort it, the array would come out 0, 2, 1, 5.
Exactly.
Which is why we have arrays.sort.
Another thing that you need to do, another thing that edge case that he does is if your V is not a node, which means it's greater than total nodes,
or less than
0, then you want to return an empty set. Which is important and that you need to make sure that you add.
So pull over the thing real quick. What's the connected component for 7?
There isn't one. So
you return
an
empty
empty set.
Because there isn't a 7th node.
Yeah.
So there's no things connected to 7, so you return that. And that's a very specific thing. He wants the output to say specifically open square bracket, close square bracket. How do we know that? Because that's what it was checking for in the test case, which was not given to us in the assignment, but was given to us when we failed that test on Canvas. So we looked at the failure, we looked at the test that failed it, and it said, is it this? And we're like, well, we didn't know it was supposed to be that, so we'll make it that.
Yeah.
Yep.
That's basically how most of this night went.
Yeah.
So we're going to set our starting node to be the node that we're past.
Yeah. So say it's looking for the connected components to 3.
Yeah. So we're going to do the same thing.
3.
We're going to do breadth first search. And this is essentially
the same as the shortest distance.
Exactly.
But we don't even keep track of the level anymore.
All that we do is we have a Boolean array of visited nodes.
We don't even use the current node to start.
Yeah.
But we do count this time.
Yes. So basically every time all of this is shortest distance, but every time we visit a thing, a node and we set it equal to true, we're going to increase count. That's all of this is saying.
So what you're doing is you're counting how many nodes there are in the subgraph, in the connected components.
So
and then that is what while loop with the for loop should look very similar to what we did before. So we're not going to go over that again. It's basically the same.
And then we have a return array because we need to get everything into an array so we can sort it so that we can then do it to a string. So return array is equal to the amount of counts, which was increased every time we added a true. We have Fido, amazing Fido.
Because we didn't want to use count again.
Yeah.
That's why.
And then whenever I is less than total nodes, I++, normal for loop. If the visited node at I is true, then we're going to put I, which will be the number,
the value of the node.
Yeah. At that position in Fido.
Fido is an int array.
Yeah. Fido is basically, okay, so if you look at this and we look at 0, and there's 4 things connected to 0 counting itself.
So everything, when you go through the breadth first search, we're creating the Boolean array, which says 0 is true, 1 is true, 2 is true, 3 is false, 4 is false, 5 is true. So then we're looping through that Boolean array and saying if it's true, add that value at the index where it's true, add that to a new array at location Fido with the value of the index where it's true.
And then basically we just sort the array, and then you can do arrays.toString return array, and it will automatically convert it to a string.
Yeah, because for some reason he didn't want an actual array, even though you're printing an array. He wants a string to print, which I guess makes sense.
So that's pretty much it. That is graph, finally. So if you have any questions, our emails will be in the end card. But yeah, we hope that you enjoyed.
Yep, good
horrible
luck. Hopefully this video can help you get it done in sub 14 hours, because that's how long it took us.
Yeah.
Yep. Thanks for watching.
Alright guys, Spike YOLO Gaming here. Welcome back to another Minecraft Let's Play. Today we're going to be...